I don't know about you guys, but after watching that Ninjago video, I think that I need to make a trip out to California so I can go to Legoland and I can ride that ride too. So our problem that goes with Ninjago is we were so excited to go to the Ninjago at Legoland, but it's the newest ride at the theme park. We started waiting in line at 9:30 a.m. and we did not get on the ride until 11 a.m. How many degrees did the clock hands have to turn while we were waiting? Hmm. So I know that a clock is a circle. So I'm going to come up here. I'm going to add a circle. Actually, I am going to add a clock that says 9:30 so you guys can see those. Okay, so we have a clock face right here. And I'm going to go ahead and put an arrow. You can add an arrow starting here. And it said 9:30 a.m. So I know it's not going to be quite at the 9 and it's not going to be at 10. It's going to be in between. I remember my shorthand is my hour hand. And then it says 30. And I know Hazik is really good about knowing his 5 facts for multiplication because he thinks about a clock. And so if I think about a clock, 12 o'clock is 0. So then 1 is 5, 10, 15, 20, 25, 30. So if I think about that and I do 30, then my long hand or my minute hand is going to have to be pointed down at the 6. So I'm going to add another arrow and I'm going to point it down at the 6. So this clock says 9:30. And then I know that I don't get on my ride until 11 o'clock. So I'm going to copy and paste this. I'm going to add another clock right here, or I'll put it over here. How about that? And I know that I don't get on the ride till the clock says 11. So my shorthand is going to be pointed at the 11. And then I'm going to draw my long hand. And if we're thinking about our 5 facts, we have no minutes. So it's going to be pointed at the 12. I want to know how many degrees the minute hand or the hands had to turn in order to make it, the minute hand had to turn in order to make it to 11 o'clock. So if I could drag this all the way over here one time, that would be 10:30. And I want to think about how many degrees are in one full rotation. So that would take me to 10:30. And then I got to rotate another half of a circle in order to make it to 11. So how many degrees would I need to add to my full circle rotation in order to make it to 11 o'clock? So you're going to have one full rotation and then one half of a rotation. I want to know how many degrees is that total. Can't wait to see your great thinking.